Pluto is a fascinating and mysterious celestial body that resides beyond Neptune within the Kuiper Belt. While it was once regarded as the ninth planet in our solar system, its status was redefined in 2006 when it was officially reclassified as a dwarf planet. From the outset, Pluto seemed out of place. Its orbit intersects those of other planets, a behavior atypical for a planet. However, this fact has not lessened the intrigue surrounding this extraordinary object in space. As we look beyond Earth in our 33 seconds quest for life, Pluto stands out as an interesting and potentially promising candidate. Despite being traditionally considered inhospitable to life, recent discoveries, both on its surface and beneath its icy shell, have surpassed our expectations. Stunning images taken by the New Horizons spacecraft and the James Webb Space Telescope are reshaping our understanding of Pluto, revealing it to be much more than a mere dwarf planet. These findings have caught the attention of scientists because they do not conform to what was once believed to be 1 minute and 5 seconds true. As we delve deeper into Pluto's concealed mysteries, questions arise about the size of this overlooked world in comparison to Earth. Is Pluto really as small as 1/1000th, 1/10th, 000th, or even 1/1,000,000th of Earth size? This inquiry prompts us to reconsider Pluto's true nature and scale in the grand cosmos. The theory of a subsurface ocean beneath Pluto's frozen exterior has gained traction thanks to the discovery of extensional fractures and the scarcity of significant craters in specific regions. These factors suggest 1 minute and 38 seconds more recent geological activity than previously anticipated. Although this theory is not new, it was first proposed in scientific papers in 2006, speculating on the potential for surface oceans on various celestial bodies beyond the gas giants, including Pluto. The arrival of NASA's New Horizons mission in 2015 provided unprecedented images and data that fueled further speculation. When the probe reached Pluto, it delivered the first close-up images of one of the most intriguing objects in our solar system. 2 minutes and 10 seconds unveiling a surface marked by fissures, ice volcanoes, and a vast heart-shaped basin. These revelations have led some scientists to hypothesize that even more astonishing phenomena might be hidden beneath Pluto's surface. For instance, an analysis of images taken by New Horizons revealed an icy basin known as Plum, located almost directly opposite Pluto's largest moon, Charon. While this could be a mere coincidence, the likelihood is low. Only 5% of models suggest such a formation without any interaction. 2 minutes and 43 seconds between Pluto's surface and a subsurface ocean. When Pluto's nitrogen-rich atmosphere cooled and solidified, the nitrogen gas accumulated in the basin, generating a weight that caused Pluto to shift into its present alignment. The idea of a subsurface ocean has persisted over the years, and images of Pluto's far side have strengthened this hypothesis. Strong evidence of such an ocean has been found in the form of a feature known as chaotic terrain, a landscape marked by jagged cracks and disordered plains. This terrain is located on the 3 minutes and 16 seconds opposite side of Pluto from the basin known as Sputnik Planitia. Scientists have observed similar phenomena on other bodies like Mars, Mercury, and Europa, one of Jupiter's moons. On those planets and moons, asteroid or comet impacts are thought to have generated seismic waves that converged on the far side, causing a similar chaotic terrain to that found on Pluto. Alden Denton, a graduate student in planetary geology at Purdue University, simulated how an asteroid impact could send shock waves through Pluto. 3 minutes and 47 second simulations yielded scientifically plausible results, suggesting that such a collision would only have been possible if Pluto had a liquid ocean beneath its surface. Oliver White, a planetary scientist at the SETI Institute in California, also conducted a geologic survey of Pluto, although he did not participate in the earlier study. While the features observed on Pluto's far side resemble those seen on other planets in the solar system, the low resolution of the images leaves some uncertainty. Nevertheless, there is a 4 minutes and 18 seconds general consensus among scientists that Pluto displays unique geological features, including a large number of cracks on its far side, which raises the possibility of a hidden ocean beneath its surface and sheds light on its potential origin. Theories about Pluto's ocean have long suggested that it was once a liquid ocean that froze over due to the heat generated by radioactive decay in a rocky core. In this scenario, as the ice melted, it would have caused the surface to wrinkle, similar to the way wrinkles form on an apple left in 4 minutes and 48 seconds the fridge. These wrinkles would have occurred due to the contraction of ice as it melted and expanded as it refroze, creating cracks in the surface. If this theory holds, the images from the New Horizons mission should show both older wrinkles and more recent cracks. However, the data from the mission primarily show cracks, suggesting that Pluto's surface oceans may have initially been liquid and then gradually frozen. Observations from New Horizons also revealed a giant rift running across Pluto's near side, extending from 5 minutes and 19 seconds the North Pole to the South Pole. This feature, known as the Pluto Rift, doesn't suggest a sudden surface transformation but rather points to the continued expansion of a frozen ocean. The presence of water on Pluto is further supported by observations of water molecules on the planet's near side, which appear to contain organic molecules. While the presence of water on Pluto might seem unlikely, laboratory experiments have demonstrated that solar and cosmic radiation can produce complex organic compounds, including bases found in RNA. 5 minutes and 52 seconds and DNA. These findings strengthen the idea that Pluto could harbor organic molecules and potentially support life. Additionally, the probe's observations revealed a reddish band near Pluto's equator, possibly composed of organic material and corresponding to a region receiving more solar exposure and warmer temperatures. This discovery is significant because it indicates the presence of liquid water and organic molecules, two critical components for life. On the other hand, some UFO enthusiasts have suggested that Pluto, 6 minutes and 23 seconds, could harbor artificial structures, pointing to anomalies seen in images of the dwarf planet, such as a smoky trail visible on its surface. While NASA attributes these anomalies to natural processes, some speculate that they might be evidence of extraterrestrial life on Pluto. Despite the exciting discoveries and the potential for hidden mysteries on Pluto, it's essential to remain cautious when interpreting such findings. While the evidence for a subsurface ocean and organic materials is intriguing, much of Pluto's environment, 6 minutes and 54 seconds, remains harsh and inhospitable to life as we know it. Temperatures on the surface are incredibly cold, averaging around -375 degrees Fahrenheit, -225 degrees Celsius, far too low for liquid water to exist in its normal state. Yet, the possibility that some form of liquid could exist beneath its icy shell, kept warm by internal heat from radioactive decay or tidal forces, makes Pluto's geophysical features all the more compelling. Despite its frigid temperatures and isolation, Pluto continues to surprise scientists with its dynamic geology and unexpected complexity. As research progresses, the possibility of a hidden ocean beneath its icy surface remains one of the most tantalizing mysteries. Could this distant world hold clues to the origins of life in our solar system? One of the biggest challenges in confirming the existence of a subsurface ocean is Pluto's vast distance from Earth. Unlike moons such as Europa or Enceladus, which are closer to the Sun and have been extensively studied, Pluto's remote location makes direct observation difficult. However, new advancements in space exploration could change that. NASA and other space agencies have proposed follow-up missions that could provide definitive evidence of a liquid ocean. Concepts such as an orbiting spacecraft equipped with ground-penetrating radar or even a lander capable of drilling through Pluto's surface ice have been discussed. If such a mission were launched, it could revolutionize our understanding of the dwarf planet. 8 minutes and 15 seconds. Meanwhile, scientists are using computer models and simulations to predict what lies beneath Pluto's frozen crust. Some theories suggest that the subsurface ocean might contain ammonia, which acts as an antifreeze, allowing liquid water to persist despite the extreme cold. This raises intriguing questions. Could Pluto's ocean be stable enough to support microbial life? If life does exist, how would it adapt to the cold and lack of sunlight? What chemical processes could sustain an ecosystem beneath the ice? If Pluto does have an ocean, it would mean that liquid water is far more common in the universe than previously believed. This has profound implications for the search for extraterrestrial life, reinforcing the idea that life might emerge in unexpected places, perhaps even in distant dwarf planets beyond the Kuiper Belt. 9 minutes. In addition to its subsurface mysteries, Pluto's atmosphere continues to intrigue researchers. Unlike most icy bodies, Pluto has a thin but active atmosphere composed of nitrogen, methane, and carbon monoxide. This atmosphere expands and contracts as Pluto moves along its elongated orbit, leading to dramatic seasonal changes. One of the strangest phenomena observed is Pluto's haze layers, fine particles that form high above the surface and scatter sunlight, giving Pluto a bluish glow. Scientists believe these layers result from complex chemical reactions driven by solar radiation. Some have speculated that similar reactions might generate organic compounds, further supporting the idea that Pluto could be chemically active. As Pluto drifts farther from the Sun, its atmosphere is expected to freeze and collapse onto the surface, only to reappear when the dwarf planet returns to a warmer part of its orbit. Understanding this cycle could provide insights into the atmospheres of other distant worlds. 9 minutes and 45 seconds looking ahead, the next great challenge will be sending another mission to Pluto. While New Horizons provided an unprecedented glimpse of the dwarf planet, it only conducted a brief flyby. A future orbiter could map Pluto in detail, study its geology over time, and even search for signs of internal heat or liquid water. Some ambitious proposals suggest landing a probe on Pluto's surface, where it could analyze ice samples and search for complex molecules. If successful, such a mission could redefine what we know about the outer solar system and the conditions necessary for life. Despite its small size and distant location, Pluto has proven to be one of the most fascinating objects in our solar system. Its icy surface, hidden ocean, and dynamic atmosphere challenge our understanding of planetary science. As technology advances and space exploration pushes further, Pluto may one day reveal secrets that reshape our view of habitability and the potential for life beyond Earth. For now, Pluto remains an enigma, a frozen world on the edge of the solar system, holding mysteries yet to be uncovered. The next generation of explorers will determine whether this tiny, distant world is more alive than we ever imagined. As Pluto drifts ever farther into the depths of the Kuiper Belt, scientists continue to unravel the secrets it has kept hidden for billions of years. But what if Pluto isn't alone in its mysteries? What if its frozen landscape and possible subsurface ocean are just a glimpse into a much larger and more complex system lurking at the outer edge of our solar system? Beyond Pluto, the Kuiper Belt extends like a vast celestial graveyard, filled with icy bodies, dwarf planets, and perhaps even undiscovered worlds. Some astronomers suspect that Pluto may be just one of many objects that harbor subsurface oceans, each potentially capable of supporting life in ways we have yet to imagine. One such candidate is Eris, a dwarf planet slightly smaller than Pluto but with a highly reflective surface coated in frozen methane. Could Eris also possess a hidden ocean beneath its thick ice shell? If so, how would it compare to Pluto's? As space agencies plan future missions, an idea emerges: a Kuiper Belt Explorer, a spacecraft designed to visit not just Pluto but multiple dwarf planets, scanning their surfaces and probing their interiors for signs of liquid water and organic compounds. The mission would be an ambitious one, requiring advanced propulsion systems to reach these distant objects in a reasonable time frame. But if successful, it could change our understanding of the outer solar system forever. 11 minutes and 45 seconds meanwhile, speculation grows about another, even greater mystery: Planet 9. Some scientists believe that an unseen, massive planet lurks far beyond Pluto, its gravitational pull subtly influencing the orbits of Kuiper Belt objects. If this planet exists, it could be the true ruler of the outer solar system, shaping the fates of worlds like Pluto, Eris, and others yet to be discovered. What if Pluto's unusual geology, its ice volcanoes, shifting crust, and possible ocean, is somehow connected to the presence of this elusive planet? Could gravitational forces from Planet 9 be stirring activity deep within Pluto's core, keeping its ocean from freezing solid? New simulations suggest that if Planet 9 is real, it might be a gas giant or even a super-Earth, lurking in the darkness, waiting to be found. A new generation of telescopes, both in space and on Earth, are scanning the outer reaches of the solar system, hoping to catch a glimpse of this hidden world. If it exists, its discovery could shake up everything we thought we knew about our cosmic neighborhood. 12 minutes and 30 seconds, but for now, Pluto remains our greatest enigma. It is a world of contradictions, small yet geologically active, frozen yet possibly hiding liquid water, distant yet still capable of surprising us. With every new image, every new study, we realize that the solar system is far more dynamic and diverse than we ever imagined.